All right, so remember as I talked about earlier, the way we prove two sets are equal, let's say, to prove that, oops, sorry about that, to prove that C is equal to, set C is equal to set D, we prove that C is a subset of D and D is a subset of C. So that's what we're going to do here. All right, so we're going to prove, first we're going to prove that A complement minus B complement is a subset of B minus A. And like I talked about in an earlier video, this is really proving an if-then statement. So we're going to assume X is in A complement minus B complement, and we're going to show X is in B minus A. Okay, so I really wouldn't put that in my proof. My proof is going to just say assume X is in A complement minus B complement. Okay, and I have above the definition of complement. It's the set of all X such that X is not in that set. Now, we'll just assume that all of this is happening inside some universal set. Okay, so assume X is in A complement minus B complement. Okay, now using the definition of set difference, that says that so X is in A complement and X is not in B complement. Okay, so now because we're assuming that we're inside some universal set, so not as part of my proof, but I just want to illustrate this. A complement is the set of all X such that X is not in A. Right, if we have some universal set U, here's A complement is all the stuff outside of A. So if we're in A complement, that means that X is over there. And if we're not in B complement, then that means we've got to be in B, right? So if you're not in the complement, if you're in A complement, that means you're not in A. So X is not in A. And if you're not in the complement, then that means you have to be in B. It's one or the other or both. All right. So now think about this, right? So we're proving that if, again, just to reiterate, I do lots of repeating, right? Maybe that's annoying, but that's teaching. So we're proving that if x is in a complement minus b complement, then x is in b minus a. So we assume x is in a complement minus b complement. So what does that mean? Using the definition, that means that x is in the definition of set difference. That means that x is in a complement and x is not in b complement. So if you're in the complement, that means you're not in A, right? And if you're not in the complement, then that means you must be in B. So x is in B and x is not in A. That's just rewriting everything. So x is in b minus a. This proves direction 1. Now we're going to prove direction 2. And the thing to notice with this is that the proof here of 2 is really just going in reverse, the reverse of step 1. Assume x is in b minus a. So the definition tells us that x is in b and x is not in a. So again, let's see. Let's say this is b, then out here is b complement. So if you're in b, then you're not in the complement. Complement would be red there. So if you're in side B, then you're not in B complement. Similarly, if you're not in A, right, then you've got to be over. If you're not in A, then you've got to be in A complement. Oops. And that's the proof.